Alright, it's time again for some cat-like coding. Let's try and see what we can do. Now, we were following online this tutorial here on the catlikecoding.com, and we got this this solution here, this something here. Good. Wait a minute. Oh yeah. We can just roll the slider here up and down, and then we can see what is going on there. In the update, the mesh is being produced, and the script is always turning itself off. This is so genius. But anyways, let's keep going. Good. Before we learned about simple, advanced, and single streams, and now we got an advanced stream with something. Now we had to write a lot of code here, and to me it looks like spaghetti. But the trade-off is that you don't have any dry. You don't repeat yourself at all, and this looks quite good. This looks great. We have a little bit of a repetition here, but it's all right. Let's see how the tutorial continues. Good. Resolution 2 grid with gaps. Yes. Plane. Grid is typically used for flat planes, so let's adjust ours. So it lies in the XZ plane. Oh, and I should mention, I'm just doing this here to learn. This is. I am of the conviction that when you follow these tutorials here with the meshes, you're gonna have an easy time of making a fantastic Minecraft-like game, and you need to understand everything behind here, the interfaces and the inheritances and all that stuff, but I don't know. It's a little bit beyond me, I gotta be honest. Let's just follow the tutorial and see if we can learn something in the end. Good. Plane. Grids are typically used for flat planes, so let's adjust ours so it lies in the XZ plane. Straightforward enough. Begin by renaming Y to Z and also close the gaps between the quads. Sure, we're going to do that. Now, where is this? Here in the multi-stream? Not even sure. Var coordinates. Going to look for where we're actually doing this in the mesh job. Maybe var coordinates. Oh, let's just search for it because I'm too lazy now to look through everything we wrote. Dum dum dum. Coordinates. Dum bum 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 bum. So in a square grid, who would have known? Not me. Good. 1F, ZZ, and 1F. Sure. 1F, ZZ, and 1. Good. Now this is gonna lay flat then, and the resolution is times Z. Good, in the Z plane. Alright, so a square grid. This seems to be the a smaller thingy we're doing. Just trying to figure out how this will look in the future. This is the object we're creating. Possibly. So if we had voxels, this would be voxel. And it's a good thing we have this slider here. We can simply have more than one. Good. Is this already functional? Just checking. Not really. Not really. Good, what else? We change the orientation of the grid by assigning to the XZ components of the vertex position instead of XY. Sure. Change the orientation of the grid. So that was functional, but it laid it out differently, right? Also, why is this not in the center of it all? Not because we don't have it in the center of it all. Wait a minute, but I want it like that. And is it going downwards now? Anyway, let's just continue. I wanted it like that to compare in the previous examples. we had this on. So that's why I had it a little bit outward. Cat-like coding, no dogs allowed, says the fat cat. The dogs are allowed. Sure they are. Good. And we're even casting a shadow here. Is that fantastic? Awesome. I love the cat-like coding.
Nothing to report.
There's nothing to report, fat cat? Aww. But no news is good news. Good, let's continue on. Vertex position XZ coordinates something. Yeah, this is down here somewhere. Yep. Good, we're gonna lay it flat now. All the Y's are going to become Z's. Easy peasy. You also have to change the normal vector so it points up. Yeah, that makes sense. Vertex normal is up here. Good. Boom, boom, boom. And it's 1F. Simply. Good. Fat cat, we're going to the mall today to let my daughter shop for her birthday. Sounds great. Sounds fantastic. Good stuff, fat cat. You have fun there. I always say nothing to report, but then there's usually something to report. Good. Let's see if we're laying flat or not. And let's reset the transform so it's in the middle of the map. And increase the resolution. Oh, this is just beautiful. This is just amazing. Can we manipulate the camera? So that the Foscom is somewhere else? Here, clipping planes. There we go. Near, far. Doesn't look like it made a difference. Near, far. I don't know. I thought this would be more efficient. Camera is looking here. Oh, this is just the camera. I'm using the editor camera, so this does not do anything. Alright. Is there an editor something we can change? Editor, clipping planes. Let's find out. Unity. Oops. Editor. Clipping planes. Editor's camera clipping planes. Is there a way to adjust? No! What? They're just public? What? If they're public, then there must be a way to adjust them. Press F to focus the object. To adjust the planes automatically. It works, but it's still claimed to give some kind of control system like mouse wheel plus control to adjust not only near plane but also the right pivot point. Sad robot standing in a corner music, indeed. Because we cannot apparently we cannot change the camera system of the editor camera. It's alright. We don't need to. It's just fine. Good. Let's continue on. But soon it's gonna be a very high upbeat Silent Hill 2 music. It's gonna feel good music. It's gonna be on a Silent Hill right now. Good. It's also convenient if the plane is centered on the origin and has a fixed size, regardless of its resolution. Oh yeah? We can achieve this by dividing all coordinates by the resolution and then subtracting half. Yeah, that makes sense. Sounds like reasonable math. Good. Coordinates. Bum, bam, bum. Good. Adjust the bounds to match. We will. Vector 0. Public bounds. Good. this makes more sense now. Good, don't have to derp around. Derp around. And we add something in here. A 0f. Good. It's a bit disconcerting to see a vector 3 here with only 2 values. Now we got 3. Good. Alright. Generating rows of quartz. Alright, but let's see how this changed everything. Good, it's in the center now. Good. Like they promised. Well, I've got some derping around. Get ready to leave. I hope you have a nice day. Thank you for chiming in, Fat Cat. Good to see you every time. Let's increase our resolution. Oh, So it does not change its size now. Good. So we can have. Oh, this is great. This looks like we can have. Oh, this is genius for a voxel game. Farewell, Fat Cat. For a voxel game, this is genius. Because then you can just increase the resolution. And if you split it up, if you have code to split it up, then it's going to be very small voxels in the end. Micro voxels. Wow. Hey, this is so cool. Good. And we can compare with the other thingies. Dun, dun, dun. Yeah, they're very different now. Good. Did we move this all the way? Yeah. Good. Compare with this thing simple. Cool stuff. Continue on. It's gonna get cooler, I promise. We'll let each invocation. Oh yeah. Generating rows of quads. Our job currently generates each quad of the grid in isolation. Really? Creating a single quad isn't much work, but the vertex data cannot be vectorized. So everything has to be calculated per quad, and Unity's job framework adds additional overhead. We can improve efficiency by combining the generation of multiple quads in a single invocation of execute. This is here the execute. It makes the most sense to generate all quads of a single row together. That will make the job length equal to the resolution, no longer squaring it. Really? Good. Job length is an integer and it gives us a resolution. Huh? Oh. Wait, what? We already have this? But now it's half in size. Or rooted in size. Good. We'll let each invocation of execute take care of a whole row of quads along the x-axis. The job index will thus represent the z offset of the row instead of the quad index. Let's rename it accordingly. Also, the first quad index of the row is thus equal to the resolution times z. Sure. This execute here, I just don't understand. Have to be honest. Good, because I'm not familiar with this style of writing code. I should have researched it. Well, we did it in the tutorial before, but whatever. We got it now. Times resolution times z. And the t is 2 times resolution times z again. Let's get it going. Copy. Bam. Wonderful. And then in C, int x. We don't need any of this anymore. Int C minus resolution int x. Maybe we don't need this anymore. Good. Now, instead of using a fixed x offset, we introduce a loop for the entire row, which encloses a code that fills the streams. Good. Var coordinates float. So here. for int x. So we don't need that anymore, right? Oops, what did I do there? Yes, they're deleting it as well. Good. For int x equals 0, straightforward loop, x lower than the resolution. Good. And we increase the x in this for loop. Good. Oh. And we encapsulate this in here. Good. So that thing goes here. And we are going there. Alright. Good, and if you're wondering, what is this? This is not how you set the brackets. Yep, well, this is how I set the brackets. Good. Alright, to set the correct quads, after each iteration of the loop we have to increment the vertex index by 4 and the triangle index by 2. Sure. For int x equals 0. Resolution xx. Uh-oh. After each iteration of the loop. Oh, this is advanced looping and you never learn this unless you follow the Catlike, and that's exactly why we're doing this. V plus equals 4 and t plus equals 2. Good, so this is very new. To set the correct quads after each iteration of the loop, we have to increment the vertex index by 4 and triangle. Good, so this is just more happening after every time. Normally, when you're done with the loop here, right, this is the first iteration, then you do this operation, and then you do the stuff again that is inside. But now we're doing this, x plus plus, but we're also doing v plus equal 4 and t plus equal 2. Good. Understood. Finally, burst can detect code inside the loop that never changes and automatically pull it out of the loop. However, it won't split vectors, so we can optimize a little bit by manually splitting the coordinates vector in separate x and z pairs. The z coordinate calculation is constant and will thus be hoisted out of the loop. Really? Shouldn't we also introduce an in-resolution variable to avoid multiple divisions? Because we use float mode, fast, burst will do this automatically when it detects repeated division by the same values. So a division is only calculated once per invocation of execute, and all divisions that we wrote become multiplications. Good. I don't know what any of this means, but it's fine. I just know we added a package burst by adding the universal render pipeline, and that is just for anything on a graphical stream is going to get optimized, I think, is the idea of the burst. But I don't know what I'm talking about really. This is just how I explain it to myself, and which is good enough for me now. Good. Coordinates float 4. So this we are going to change somehow. Variable x coordinates good equals float 2, and then we have an x and an x plus 1f. Good, I'm typing this. I could copy paste, but I'm typing this now. Resolution minus half an F. Good effort. Alright, and then the same for the Z. That's what we're doing up there. Is this correct? Nope. And we have another Z here. Alright, makes sense, maybe. Good, and then vertex position XZ is what we're changing. Wait, why do I have this here? Is this in? Variable vertex, new vertex. I don't see this anywhere here. Well, I'm at a loss. Vertex position X, vertex position Z, we're gonna do instead of vertex position XZ, coordinates XC. I guess. And they did not mention that we have this there. There's some dots missing. I hope that's it. And I hope we don't need to mess with this. Alright. Good. Let's just paste this one in. Copy. Paste. And then we have a similar thing down here. Good. Dum dum dum. Where the text coordinates are. Good. And then we have another single line of code. Here. Where there is more text coordinates. Why are you overwriting this? Don't understand this code. Good. Next tutorial. So we're done with this tutorial. Does it work? No. 25. Good. A local variable function named x coordinates is already defined in the scope. Oh, this is a z coordinate then. Good. The name coordinates does not exist in the 41. Why not? What did we miss? Vertex position X, Z coordinates. I thought we deleted that. Did I delete something I shouldn't have? Or did I copy over something? Probably. Float 2 1F 0F? No, we did not do this proper. Good. So this goes above the 1A. Yes, we did this. Those two go on top of the 0 something here. Good. And this goes on top of the other text coordinate. And this here goes above the stream set vertex V here. Good, and then we have this there which does not show up here. But maybe it's fine. Good. See how it looks? It looks exactly the same. But now it uses less power. Computing power, that is. Good. Alright, that's fantastic. Next one then. Next tutorial is a modified grid. Good, sharing and shading. Create a grid variant with shared, shared vertices. Make a shader that modifies vertex data. Apply a rippling animation to the grid. This is a tutorial in a series about procedural meshes. I think this goes in a different direction now. From voxels. But it's fine, I see them have cubes later on. We're gonna build upon this code for sure. Good, this is a second way to generate a square grid. Oh, what? And a way to animate it via a shader. Good. Second way. Wait, what? The original previous is made of independent quads. Each grid has two turns to share two vertices, which is share vertices. This allows each grid to have its own texture coordinates. In our case, they all cover the full 0 range, but this need not be so. Each quad could have different texture coordinates, which could be used, for example, to show different parts of a texture, potentially with different scales and orientations as well. However, in many cases, there's no need for independent quads. Typically, a single texture gets applied to the entire grid. In such case, we can drastically reduce the vertex count, and thus the size of the mesh, by having quads share vertices with their neighbors. Good, we're going to support a vertex sharing variant of square grid. Begin by duplicating it, renaming the version to share square grid, leaving all other code the same for now. Good, we skipped the pseudo-random noise. And we're going to skip this one here as well. Good, let's see. Tutorials procedural meshes. Third tutorial in the series of procedural meshes. Yep. Good, supersedes mesh basics. Good, rounded cube. So this is less advanced than the other stuff. That's a bit bad. Procedural grid. Deformable balls. And this here is extremely interesting. I wonder if I can apply this to a 3D grid and get a world going somehow. And the idea would be to have the player at the center here all the time. It's just more of an illusion. There. But how would that look from here? Don't know. Actually, finish it. Let's do the rounded cube tutorial. Create a cube with a seamless mesh. Add rounded edges to a cube. Define holes, edges. Follows procedural grid. I think that's the one we made here. No, that's not the one we made. It has been made really and up. Compositing a cube. Next is procedural grid 2D structures. Let's have a look. Cube. Creating cube vertices. You need to create new components. It's supposed to be some code from previous tutorial. New thing right now is the third dimension, so we have to add a Z size. So once again, use code just so to visualize what's going on. Good, public class cube. Yeah, let's do this real quick. This is an easy tutorial. We can squish it in. Good. No problem. Let's close this off. Procedural meshes. Maybe put it in here or in there. Let's put it just in here in the scripts. Create a C# script cube. And see how it goes. Cube. It opened, so I thought it would hide this and I couldn't scroll, but it's alright. We're gonna copy this code. See what happens. So first of all, we're going to, there is no collider. Good. How's this looking? Alright, we're gonna give ourselves 3 integers. That makes sense. We give ourselves a mesh and a vector 3 with the vertices. On the awake method, we're going to... so we learned that we can put this in the update, but let's not do it now. Or should we? Could be nice. Now we have a different size for a cube, but let's follow the tutorial a little bit longer before we mess around with it. Now, in a coroutine, we are generating the thing. Procedural cube, sure. Good. So we generate the slow? No. Good private void undraw gizmos. If vertices on a 0 return. Gizmo's color is nice. And he has a bit of a loop. We draw a sphere with vertices. And every time I see this private, I think, what the hell. Good. Wonder if it needs to be private to work. We're definitely going to find out in a second here. Good. Let's see, we don't need that. Good. I guess we'll alright. Now this thing we're going to not have. Let's see what the Catlike wants from us. Good. Now you can add a new game object into the scene and turn it into a cube by adding this component, or replace the grid component of an existing object. Do not have an existing object. Let's create an empty, call it proc cube, and give it the cube code and run it. And there is no cube. What? Why is there no cube? Oh dear. Why is there no cube? Because the size is wrong? No? Zero triangles. I guess we're not done with the tutorial. Is the problem. Can I zero this all real quick? Apparently not. Good. Now you can actually go adding the third dimension. Before we can add the vertices of our cube, we have first to know how many they are. We already know the amount of vertices needed for a single face, so we can just add 6 faces together to get the total. However, as the edges of the faces touch each other, the vertices will overlap, which leads to duplicate vertices. Each of the cube's corner vertices are tripled, while all vertices along its edges are doubled. This doesn't need to be a problem. In fact, vertex duplication is very common, as it is used to create sharp edges in a mesh with normals. So we can create the 6 sets completely separate from one another, just combined in a single array, but that's not what we're going to do, because we already know how to create grids. Our cube won't have duplicate vertices. It's more interesting that way. So how many vertices do we need? Let's break it down by type. First we have 8 corner vertices, that's easy. Then we have 12 edges, 4 in each direction. As we don't include the corners, each edge has an amount of vertices equal to the corresponding size minus 1. Alternatively, think of it as 4 sets of an x, y, and z edge. 4 sets of z edge? 4 sets? Why 4? 1, 2, 3, 4, I'd count 6, but whatever. The remaining vertices are those that lie inside the face. That's equal to a cube with the duplicated vertices that has its size reduced by 2. Now we finally know how many vertices we need. Ah, finally. Good. Let's put it into the coroutine after the wait time. Good. Wonderful. Positioning the vertices of the first face row is exactly like positioning the first row of a grid. Good. Vertices equals new vector. Good, where is this? Down here. Position vertices of the first face row is exactly the first row of a grid. Yeah, we haven't done this, so we don't know. Good. Why increment v when accessing the array? It is each time we assign vertices into vertices should increase. That's what I'm doing. The rules of vertices should be done with vertices and never vertices. We never need to worry about incrementing v somewhere else. Of course, you could instead increment v in the same place as loop iterators. Nothing wrong with that, as long as you're consistent. Just demonstrating a different approach. Good. Then it gets more interesting. Let's continue with the first row of the second face and so on, creating a square ring of vertices. This is done by looping 4 times using different ranges and positions. Good. Sure. Good. And how does this look so different? Oh, because it's not my code. Let's go over it and pretend we know what we're doing here. Corner vertices, edge vertices, face vertices, vertices, new vector, corner vertices. Just collecting vertices here, that's fine. And v equals 0. Then we have a loop here. Oh, we put this in the wrong place, I just realized. Uh-oh. You need to return weight. Ah, this must be in the loop? This must be in the loop. Good, make sure it looks nice. And yes, this looks nice to me. Minus. Good. This is just crafting it. Logically. The thing there. Good. The bottom vertex ring appears, does it? We can turn this into a complete wrap around the cube's height by repeating. But it says something appears now. 58. Something on draw disk gizmos. This is inside of the thing. Good, I hope I haven't forgotten anything here. Surely that will work. Aha! The bottom row appears. Apparently. Oi. Hey. And the cool thing about this is, we're waiting a little bit of a time there. Good, but this is too slow for my taste. Yield return null. Good, because that will return just a single frame. Wait, new wait for seconds. No, we don't need this. If anything, this should be... Hold on. Why is this in here? Good. Public. Wait. Public wait float. Good. New wait for seconds. This is crazy pants. Will this work? Let's find out. No. Type on namespace wait float. Oh, of course. Sorry about that. This is a wait for seconds. Of course. Copy. No. And the name wait doesn't exist. Oh, that's fine. Good. Alright. Good. And can we make this? Hey, where is it? Where are you going? That is funny. That is funny. It does not show. It doesn't show. Serialize object. Is that how it works? No, that's not how it works. Serialize. How do you serialize? Serialize field is how you serialize. Oh. Yeah. Definitely. Serialize the field. Good. No, it doesn't want to. It doesn't want to show up in the editor. Good. We're gonna do without then. Good. Just found a new limitation. No. And no, that's a single frame. Going to wait here. Bzzzt. A single frame is enough. There we go, we have it. And if you put this all in the update and if we implement that trick we learned, we could have something else. Ooh! What is going on? It's laggy. Oh, this is extremely laggy now. Waiting a single frame? No such luck. Look at this lag away. Clearly this is not optimized code. Let's do a 4, 4, 4. Yeah, that you can do. Let's do a 44, 44, 44. And that you can do as well. Alright. Good. Let's continue on. We can turn this into a complete wrap around the cube's height by repeating the ring placement along Y. Aha! So we place even more rings now. Good. Copy. We encapsulate all these 4 loops into yet another loop. Oops. Like so. Alright. For Y size, Y. Good. We're wrapping the cube. After that we have to cap. Alright, let's wrap the loop for a moment. Is 44 too much? We're gonna find out. Where is it? I don't see it happening. Let's do only 11. It doesn't look like something's happening. Wrapping the cube. What is supposed to happen? Yeah, it doesn't work. Why not? This is crazy pants. Looks like it does the same as... Oh, we did not save, did we? Oh, we did save. What? By size. If you do this again, but you don't, why? Why wouldn't you? Huh? What did we miss? Versus in v for x equals 0. Then x size here. And then we do it again, but put it up a little bit. Don't get it. Did I manually type something? The gizmo drawing is working. I don't get it. It also does it quite instantly. Maybe that's the reason why. Where do we encapsulate here? No, here. Cap the top and the bottom. Doesn't want to do it for me. It really does not. 4, 4, 4. I think it does it, but it stays down there for some reason. Oh, I can move this, but it does not do anything? I thought this was an easy tutorial. After that we have to cap the top and bottom. I just fill the holes like a regular grid. All the cube vertices, no duplicates. Cap the top and bottom. After that, so after this loop, put in yet another loop. This one. Huh? How is this only one when I copy this all? Copy? Weird. Z and Z. Anyways, I do understand this code. But it will not fire because it didn't fire before. Anyway, let's see how it looks. Wait does not exist. Turn no. Oh. Maybe that is actually the issue. Maybe I do have to have this for some reason. Wait longer than a single frame. Oh, this could be. And they didn't mention it. Alright. Yeah. It does something. Out of range, index is outside the bounds of the area. Yeah. It needs to wait for more than a frame, or it needs to be somewhere else in the fixed update, but instead of just in in a single frame rate thingy. Alright, alright. That actually makes a little bit of sense, but still, I don't like it. But it is what it is. Good, copy. Wait for seconds. Boom, 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 copy. Let's wait it out and then it will work. Terrible. Alright. Boom, 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 boom. Ah, I was so sure we would be working now. We just have a little bit of a code error here somewhere. Possibly where I typed. But where did I type here? I just copied everything over. Did I not? So the driver application and code vertices 8. Vertices new vector 3, code vertices edge vertices face vertices. Good, vertices new vector. And then we have int v. And for y equals 0. Alright, this is the x then. We're going to squish this in later. I don't get it. Also, what the heck is going on here? Maybe I'm gonna redo everything. This doesn't look right. We put this in here, sure. And then we wrap around a y. And then we put in 2. Good. But where do we put them in? Into the generate. Not out of the generate. And after we're done with the encapsulating loop, apparently. Good. Why are we doing 2? I do not know. And wait. Because the gizmo draw is slow? I have no idea. Good. Top level 68. Oh yeah, this is something here. Something we're missing. Good. Where is this from? From the generate. This looks like we might be alright over here. And before you say that's what you get for putting the brackets there. No, that can happen anytime. Now, let's see how this looks. Still the same. And it's gonna draw a little bit on the top. Oh, and in there. What is happening? It's like some of these they refuse to draw. One submesh. Do not know. The only option is to do everything again. Because I have a mistake here somewhere. I'm sure I have a mistake there somewhere. Let's go nuclear. And paste in everything again. Good, copy. I don't like to do this, but I will. Paste. Alright. And then after the wait for 6 seconds generate, put in this. Good. Then after the vertices, we paste in that. And then after the first for loop, paste in the other 3. And then we encapsulate. Oh, I completely missed the Y's here. Ah, and nobody told me. Oh, man. Alright. That makes sense then. Good. Is this in the wrong place again? Alright, right. Hey, wait, I can undo everything I did here. Whoosh, this was overriding everything, I think. Yeah. Alright, this is what I meant. X, Y, Z, and this is 0 there. That's the problem. Y, and then we're gonna null the weight again. But first, I want to see how it works. Good. Now we're talking. Good. Aren't there some missing? Put the directional light somewhere else. Nope, everything is fine. Good. Yeah, this clearly is too slow. No. Good, copy. And here as well. Also, I want to wait in this loop as well. Is this a double wait? We're gonna see. Whoosh. Oh yeah, that's so much better. Good. So yeah, that means it has nothing to do with this. It was just user error. Wait for seconds, don't need. Good. That's better. Alright, let's make it crazy. See how it looks. My graphics card is whirring. So this is already graphics apparently. Of course we're having a mesh here. That is definitely graphics. It's going to take forever. What is, even though we have only 1 frame wait. So what is the next then in the tutorial? Creation of a single what is exactly the same of the grid. Yep. Oh wait, what? Adding the triangles, that's right. Now that the vertices are correctly positioned and we're familiar with the order in which they are placed, we can move on to the triangles. To prepare for that, I've removed the coroutine stuff and added separate methods to the creation of vertices and triangles. And of course, the vertices need to be assigned to the mesh. Prepare. Remove yield statements for vertices. Remove yield statements for vertices. Sure. just added them, but alright. Boom, 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 boom. Boom, 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 boom. Da, 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 dum, dum. Here. Alright, we prepared. Then in the awake method we generate. Good. That we should do in the update method. And turn off the whole script. That's what I learned in the other tutorial. That's a good trick. And if you mess around with the data, it's going to validate itself and turn itself on for a moment. Anyway, void generate. Create vertices, create triangles. Mesh name, procedure, group. Good. And then we're closing, huh? This is our closing statement. Private void create vertices. Let's probably go in here. Void. No need for that private stuff. Create. Doesn't do anything. It really doesn't. Vertices. Good. If I'm wrong, please correct me. What is the use case? Because I haven't found a compelling argument to even use that private there. It's like, oh, but then something cannot access it. This is a bad thing. That's not a good thing. But alright, mesh vertices. Where are they? I don't know what they want from me here. Let's see what is going on here. Ah, that's a huge cube, almost done. Vertices there. Create vertices. Mesh vertices equals vertices. Good. Mesh vertices equals vertices. At the end of the create vertices. Good. Here? Apparently yes. But surely that's not right. Maybe it is. Mesh vertices. This all looks good. This looks excellent. Good. But we have to get in the that we did. And then a private void create triangles. Good. Create triangles. Oh, we have this somewhere. Where do we have this? Oh, up there. In the generate. In the generate void. Good. Create the triangles. Just like that. Good. Not gonna save because it's gonna get confused if I do. Faster! Where's the faster button? Well, it's almost done with encapsulating. Good. This is fantastic code. I love the Catlike. They really know what they're doing. Good. Fantastic. More is getting done. It's like a video game. Let's not. This is a bit much. We're gonna do 22. No. We're going to do 11. And show it off real quick. This is something we can wait for. Paint it in. And we're done already? What about the middle places? No, of course it's just the outer shell is the mesh. Good, so we did this all now. Let's save it and see if it throws an error or not. No, of course not. Then, the creation of a single quad is exactly the same as for the grid. As we'll end up creating quads in multiple places, it's a good idea to create a method for it. Private static int. The heck is this? And where do we put it? Let's put it even here before the awake. And again, no need for any of that private stuff. Good, we have an int. And this is a quad we're setting apparently. Int array, int I, int v00, int v10, int v01, int v11. Oh man, oh man. Good, whatever. That's alright. It's completing domain every time. Horrible. So annoying that did not used to be in the Unity. Unlike vertices, the number of triangles is simply equal to that of the 6 faces combined. It doesn't matter whether they use shared vertices or not. Good, take your word for it. Create triangles. Creating first triangle row is once again the same as for grid. The only difference so far is that the offset for the vertices in the next row is equal to an entire ring of vertices. Sure. Good. Why not? Alright, for a cube, up. Set triangles, mesh triangles. First triangle row. To triangle entire ring. First triangle. Wait, what? Is it now only showing one row of triangles? Yep. Good, also something's wrong here. We do not have a material. Let's give it the default material then. Yeah, that's better. Why is that not showing me the texture? Because we're not writing the texture. Good. So this is the first row. This is too big. Oh, why is this now instant? Oh, because it's no longer coroutine. We're not waiting a frame. Alright. To triangulate the entire ring, let's just be naive and lengthen the loop to go all the way around. Ring, bada bim, bing. Q ring. Oh, this will throw an error. I mean, this will produce not the result that we're looking for. Yeah, it has an open door here. Ah, that cube is so big. Let's make it 8. Let's make it 4. Now we can actually see. Good. So we've been too naive here. Clearly. This works except for the last quad. Its second and fourth vertex need to rewind to start to the ring. So extract it from the loop. Ring -1. Extracting it from the loop and then T set quad. Good. T set quad. T equals 0. 0 equals set quad. Huh? Q and V. 0. What is this code? Oh, then we make it something else. Alright. So this is how far we're in to generating the thing. Good. See how it looks? Of course it looks beautiful. And goes all the way around. Complete ring. To triangulate all rings, once again simply repeat the process along Y. Notice that the vertex index needs to be increased after each ring, because our ring loops are one step shorter. Good, let's put it in. About here. Good. Make sure it looks nice. Good. Y size, Y and V. Good. And is there a way to get rid of the completing domain every time? Maybe, but I doubt it. I already did all I could for that, but let's search for it again. Unity completing domain every time. Every time. Long time stuck on completing after any code. Good. No, I never have a problem, at least not always. Simply takes half a minute to compile. Change code. But just a preference not as an address. Just a PCR depends on the same as check from the separate different unit completing the bonus into the MB. From just jump to Unity and EC3. So work with the burst compiler and where your time is plus minus 10 seconds. Without the burst compiler. But sometimes they're able to test some things in the next time I did a script modification and press control domain took me 10 seconds. Good, this wasn't happening before Unity. Anyway, I will keep the burst compiler disabled. Control R during the awareness forces Unity the real that it is simplifies the approach, shortens the time to wait. Every unit I know has existed for about 2 years now, and Siri said there's not, at the very least, like a band-aid fix the control button try to rerun it goes on too long. Not to mention there's no green, it is even stuck. Running into a problem. My iteration time is varied from 7 seconds over 2 minutes. That's the stupid burst compiler at fault. So every time you use the universal render pipeline, you bog yourself down. That's terrible. Badly with synchronous burst, asynchronous but great. And great with burst off. Per machine setting. Latest burst version. Try running burst off completely, thanks. I don't know. Bursting on starters is synchronous burst, at least I'm just a lot bigger, much better than system structure process baking plus burst. Disabling burst in the editor speeds it up a lot. Which amazing must be enabled when optimizing testing build performance. But it's a kill of iteration, unfortunately. Good. DNOF mod. View postcode, do so copy paste, me enabled internal script. Enabled internal visibility. Press editor options available. You could have send works now. Good. Unity disable burst in editor. In the edit project setting burst. Editor project settings. Here's a burst. Enable burst? No. No. Good. Project settings. Here's my material, by the way. Good. Ah, Jesus, thank you. Thank you, thank you, thank you. Oh. So of course we're going to re-enable the burst every time we build it for out of editor testing. But this is so much better. Wonderful. I'm glad I found this now. Good. Back to the tutorial. Right, unfortunately the tutorials are not straightforward. The vertex layer is like a grid surrounded by a ring. Let's start with the top face, giving it its own method. Good, why not? Create triangles. Mesh triangles, triangles. Create top face. Good. The first row follows a familiar pattern. Private int create top faces. Good. So we're gonna give it its own method, really. Sure. Let's do that then. Looking good over here. This is code. Just some math, basically. See how it goes. Up. Wait, what? What's the deal? Alright, that's just one. Good. Create top face. First row. It gets more complicated for the next row. It is useful to keep track of the row's minimum vertex index, which lies on the ring. The other index to track is for the middle part, which is the grid. Good. We're returning T somewhere here. Create top face. Looks alright. Completing domain again? Huh. Oh no. Oh no, I thought I had... Oh. Damn it. We already did everything we could. Oh. Was this on play before? No. So, I thought I found it. Oh no. Alright, let's continue on with the tutorial. The middle part of the row is quite like a regular grid. I'm sure it is. Set quad. So before we return T, we're doing this over here. Seems reasonable. We don't do my completing domain. Oh, I cannot get rid of this. And I don't see a difference from having this enabled or not. Cache is just disabled as in the editor. I looked for this. I thought I found it. Damn it. NT disable burst in editor. You're going to any edit projects in editor burst and uncheck the enable burst checkbox. Sure, disable burst. Get the Linux. Good. Burst for standalone builds via code. Burst user guide. Burst user guide. I've disabled burst compiler, we want to still get. I'm trying to build Linux again. Disable burst on runtime. How do you remove the burst package permanently? Good. This was a dependency, but that is besides this burst. What's that file? Turn off burst. Disable compilation. Project settings. Turns burst off. Does it now? Burst disable compilation turns burst off. How? Command line options. You can pass the following options to the Unity editor on the command line. Burst AOT settings. That's what we have. Disabled warnings. Here is no command line. Damn it. Let's turn it off everywhere. Is this in the editor? This is Windows, Universal Windows Platform. And this is Windows Mac Linux. Maybe it works now. I doubt it. But let's try. Let's continue on with the tutorial and then save and then see if we're bursting again. Good. Int vmax. Int vmid. Alright, and here after the loop. We mess with T again. It's gonna be charged to the loop to take care of all the thingies. Good. T set quad. T set quad. Oh, this is not the what? Here's the loop. Here we go. For this all and that. And now it should work. Are we bursting? Oh, we're not bursting anymore. We did find it in the end. Oh, not all returns a value. Error. So maybe that's why we did not burst. Not everything returns a value. Dum 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 dum. That's fine. Everything will return a value. I promise. Good. Oh, and we still have the bursting. Damn it. Oops, and it's not working. So we made a mistake here somewhere. Or not? All but the last row? Could be on purpose. Let's introduce a top of vertex index. Then use it to set the first quarter of the last row. They introduce it where? Int v top. No idea. Then loop through the middle of the row. This is never going to work. Because I don't know what I'm doing now. And finally the last. Good. Complete top face. Burst me. And then go. I'm missing something here. Cube line 14. Oh, that can't be right. You won't have to do everything again. I'm sure. Set quad. Where were we doing this? No idea. Set quad triangle. This once again has to do with outer triple matrix as well. Oh. But at least it shows me the whole thing, how it's supposed to look now. Create bottom face. Create triangles. Oh no, this is supposed to be in the create bottom face. Create triangles. But up here. There's a different, maybe the first row. This is showing the top face somewhat. V-top. Yeah. Create bottom face, copy. And then compare. Good. Get rid of this stuff. So it's returning an integer. Just like the top face. Good, this is how we're looking. Let's compare int v1, int v ring size. For that. Good, and then we do that, and then we do this. Then we do this, then we do that. Where is this loop in? Loop in. This might be there, no. No idea. Just expecting a different outcome now. But the lower thing works perfectly. Good. Made a mistake somewhere. Because we did not take great care to even implement this. But I think we could. Create top face. Create vertices. Create triangles. Create bottom face. But why does this work now? Where are we calling this even? We're not calling it. We're not calling it, and yet the bottom face is in. Oh, it's not in. Alright, that makes sense. Let's see if it would work in theory, but maybe yes, maybe no. Good. Create top face. Create a rounded cube. Create bottom face, create bottom face. In the create triangles method. Good. Good. Let's see how it goes. Boom, 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 boom. Index out of range now. And there's the bottom face. Good. Alright. Now we have to fix the top face. Complete top face. Finally, the last quad. Create top face in the last quad. Is this in the last? First quad. Next row. Next row. Create top face. Good. Create top face. Ay, ay, ay. I just want to create the top face here. Good. Creating the top face. Dun, dun. Good. Int v ring y size. Yes. And then we're going to return t. Simple. Then gets more complicated for the next row. But no problem. We can simply put this in. And then we're returning a t. Good. If this is way too complicated for me. Just copying pasting here. As you can probably tell. Set quad triangles. Middle part of the row is quite like a regular middle part. Incidentally, in the middle of the code. Good. Sure. Last quad of the row once again has to deal with the outer ring. Vmin vmid. Good. And then we're going to set the quad after the loop. Wait a minute, what? Vmid here? But then it's there. Is this in the different thing here? Set quad 4. Where is this coming from? Oh, it's here. But where is this then? Did they move it? This is the top face. But don't we have this already in here? Middle part of the row. In the middle of it we put it in. Good. And there's something on top of it. Ah, we put it in the wrong space. Good. Set quad triangles here. It's not in the middle of the code. Good. Then we do the mix, and then we do the T down here. Good. This can be turned into a loop to take care of all but the last row. Let's turn it into a loop. Good. But only last part here. Good. Make it pretty. Oops, I pressed insert. And here. Wonderful. This looks alright. Let's introduce top vertex index. But where? Then use it to set the first quad of the last row. Yeah, I don't know where to put this now. Create top face. The T is again in the wrong space. How does this happen all the time? Good. It's alright. Good, burst me in. And then we're exactly there. Out of range exception? How is this not working? Oh, we're in the loop here? No. No idea. Let's start over. Let's start over. Create top face, copy. For the third time. Until it works, we're gonna do it. Good. Creating the top face here. Right, having a for loop down there. Good. And this should look like that now. Good, index out of range. Set quad triangles. That's because we're doing the bottom too soon. Good. No big deal. Clear this. See if it goes. Yep. Alright, now we're back on track. And then we're gonna do this here. Again. Before we return the T. Easy peasy. Wait, what? I say before we return the T, not after. Good. First quad of next row. Good. There we go. There's the first quad of the next row. And then the middle part. And this time we're going to put it in the right spot. Wonderful. Good. Make it very readable. See how it looks. Looks fantastic. And then the last quad of the row once again has to deal with the outer ring. Sure. Good. After the loop. Doing this there. Good. And that's how it looks. Now, this can be turned into a loop and to take care of all but the last row. Now that makes sense for me, to me. Good. Set quad. T set quad here. Yep. That is why. Good. Alright. Anything else? No, this looks alright. Let's see how it looks in the editor as opposed to in the editor. Wait, what? Index was outside the bounds. We get an out of bounds error here. What? I don't think they get an out of bounds error. It's just us. Good, we're trying to turn this into a loop, but we're getting an out of bounds error. And we're just copy pasting here. All but the last row. So maybe the error is part of the spiel. That could be the case. See how it looks? Good, it's burst compiling alright, and then... No. It's not part of the spiel. Have we done this before? Int vtop. Then loop through the middle row. Finally the last quad. Maybe it's because we don't have the numbers there. What are the numbers? 3, 4, 2, I think. X4, Y2, Z3. Probably has nothing to do with that. It has everything to do with that. For some reason. Huh. Alright, let's continue on with the tutorial. Let's introduce a top vertex index and use it as a verse, but where? vtop vmin minus 2 set quad. Int vtop. In the top face? Or in the triangles? No, we're still doing the top face. So I'm thinking maybe here. But I have no idea. Let's try. Good. And finally last. And this should be there. Complete top face. Let's see if this is correct. Oh, what am I doing? What am I doing? Good. Clearly there's an issue. Does not show me the wireframe either. The bottom face is the same approach as a different result method. Good. And we're out of bounds again. How is it? I just wanted to squish in this small tutorial to get the boxes going. Doesn't work. Create bottom face. I did this. I don't know where the error is. Also, this all does not work, which is disconcerting. Something there is wrong. Something there is very wrong. Alright. Maybe this doesn't go into the top face, but shouldn't it? Let's introduce the top vertex index, but where? Maybe in the end instead? Before we return T, but it does not tell me there. VTop. It is before the T. surely that's gonna be fantastic and working. But I don't know. It's crazy that it didn't work for the numbers. No. But that has maybe something to do with the numbers again. 3, 2, 4? 3, 2, 4. Nope. 4, 2, 3. Oh man. There's nothing to do, but this looks now like we're using the tutorial numbers. Still. We're going to have to redo the whole tutorial. I'm sure. There was something we were missing. Maybe even in the beginning. But this is how it's supposed to look. Unity package, we could just grab a package, but no. This is not. Create bottom face, copy. But there we didn't do anything else much. I don't think. And the problem is in the top, not the bottom. Actually, this is in the middle-ish part. What if we put the top somewhere else? Oh, this is the bottom. No, 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 no. V top min 1, V top min 2. V top min 1 in the bottom face, and in the top it is V2, yeah. No. I don't see anything we did wrong. And we top face. Maybe the create triangles. Create top face, create bottom face. First row follows a familiar pattern. Create top face. Good. Create triangles. Create top face. Triangles. Triangles. Good here. In 0. This is in the create triangles. Why is this so much? Because they're adding these two in. No clue. Should be working. Set quad triangles. Ring -1. Why is this throwing an error? And it also was wonky looking here already. Except now it's fine. Good. Let's try a bigger one. 40, 20, 30. Good. And now we try double the size. 8, 4, and 6. No problem. Now we paint in the top. And now the problems begin. I'm sure. Yep. Makes out of bounds. Let's make it small again. Huh. This works now. Without a hitch. Only the big one doesn't work. Maybe the tutorial is broken. Maybe it's not me. Good, if this works without a hitch, maybe the other one works without a hitch as well. Nope. So the bottom one, which we just copied, is breaking it. Just copied it in, create bottom face. We literally did not change anything. That is a broken tutorial. Oof. Create bottom face. Let's not. And instead see it working here for a brief moment. Good. And now we increase the size. That's fine. And here it breaks. It can't be that I increase the Y size and it breaks then. That is a broken tutorial. There's a mistake there somewhere. Y size 2. And I suspect here somewhere in the numbers we need to add in a Y size instead of the number here +2, for example. That is probably the Y size. But in the bottom face it's broken as well. V +2 -2. Here we're doing the roundness. Good, but there is no way to find this out now. There is no way. Good. To recapitulate, we're trying to get the voxel game done. And for that we need to learn how meshes work in Unity. So we're learning a little bit of Unity. What is really interesting is the multi-stream approach of making meshes. And we just went to squish in the cube tutorial here real quick. But that did not work out. Possibly because I don't understand what I'm doing here really. But this looks like we have to somehow take into account the Y size a little bit more carefully. Now this looks like that. And this here looks exactly the same. Why is the bottom there not working? This is really disconcerting. But I think it's just because the counting error there somewhere. So if we do create the bottom faces, maybe it's in the wrong space. Maybe we have to put it on top of the quad. Let's see. Flipster, good to see you. Looks a bit more complicated than my mud cooker, but easier to control, that is for sure. Is it easier to control? Maybe. Good to see you, Flipster. Good to see you. But we're nearing the end. So one thing what we're trying to do is find out if this is in the wrong place. If it is, then alright. Good. Otherwise we're gonna have to dig through the code and find the error in the tutorial. That would be bad. Create top faces and yeah, we have to find the error in the tutorial. And we probably will not do this. We're gonna move on to a different tutorial. This thing here probably is not the right way to go on about it. On the other hand, if we know how to do the meshes, we can somehow merge these codes and get cubes instead. but I have no idea. Probably not. Good. So let's see how it breaks, because we just copy pasted the code and it breaks. That's not cool. Maybe if we have it 3 high. Maybe if we have it only 1 high, the bottom that gets drawn. Yep. We have it only 1 high and the bottom gets drawn. So I don't know what is the mistake here, but clearly the tutorial is somehow taking something not in account. Flipsa says, but the cooker is amazing with 3 weight plates each holding 20 kg of mud for popping them into dirt. It produces over a ton of dirt a day and keeps up 60 to 20 berries with water. That was my amazing afternoon. Good stuff, Flipsa. Good stuff. Making it happen in the auction not included. But we're done with this, with a sorry end of the tutorial. We just copy pasted most of the time and try to understand how this works. And apparently we do have a QB thingy here. Rectangular shape. 3-dimensional. But the numbers cannot be configured dynamically. It only works with a 4, 1 and a 3. That's a bit sad. So next time we're going to move on and do something else. Maybe I'm going to check off stream. Try and to understand this code. There's a lot of reading and seeing what is going on with the numbers. But alright. Thank you so much for watching. Thanks for chiming in. Don't forget my free wheel spin giveaway on the 1st of every month. And I'm going to see you tonight when it's time again for the Fallout New Vegas. Thank you, Flipster. Good to see you. And until next time, have a good day and a good night.